While advances in battery technology have allowed significant advances in the range and performance of electric vehicles, another rapidly emerging option promises yet another step change in decarbonized vehicle performance. Green hydrogen refers to hydrogen produced by the electrolysis of water using renewable source electricity. It solves many of the limitations of battery-based vehicles. It offers a far higher energy density than batteries. Vehicles powered by it can already travel twice as far on a tank of hydrogen compared with their battery-powered counterparts. Quite simply, green hydrogen can decarbonize applications where renewable electrons simply can't go. But hydrogen does bring with it some challenges, notably the very high pressures and low temperatures needed to contain it. Hello, my name is Keith Larson, publisher of Control Magazine and ControlGlobal.com, and you're listening to a Solution Spotlight edition of our Control Amplified podcast, sponsored this week by Emerson. Talk more about the challenges posed and opportunities presented by green hydrogen in transportation applications. I'm very pleased to have joined me Genny Fultz, Product Manager, Marc Butler, Director of Application and Innovation, both with Emerson. Genny, Marc, a real pleasure to talk with you today.
Thanks.
Well, to start things off, Marc, maybe you can speak a little bit to the challenges posed by green hydrogen in terms of pressures and temperatures to get a sense of the scale of the issue, not only for its containment on our cars and trucks, but also for safe and accurate custody transfer when it comes to retail gas pumps.
Well, sure, I'd be glad to cover that. Over the last 25 years, we've learned a lot about delivering high-pressure gas into vehicles because of all the experience we've had with compressed natural gas fueled vehicles. And hydrogen fueled vehicles are very similar. It's a little bit different in that most of the vehicles that use hydrogen gas as a fuel are using it in a fuel cell instead of in a combustion engine. But there are certain things that make it very similar, and that is that the dispenser, which is used to fill up the onboard fuel storage for the vehicle whenever it comes into the station, has to have the ability to measure really dynamic flow conditions that occur as the pressure equalizes between the station reservoir that's filling the car and the onboard storage tank on the car. So this creates really dynamic conditions in terms of flow rates, and pressures, and temperatures. And it's even more pronounced now with hydrogen vehicles than it ever even has been with CNG, because in order to get the range that the vehicles need to have between fill-ups, we have to fill them to an even higher pressure than we ever did with CNG. So the challenges that we were so familiar with and accomplished that with the compressed natural gas dispensers are even more pronounced with hydrogen. But as it turns out, we're more than able to handle those.
It's been just about 2 years now since Emerson introduced the Micro Motion HPC015, a compact Coriolis meter suitable for accurately measuring the flow rate of high-pressure hydrogen in dispensing applications. How has the uptake for that product been since it was introduced?
We've seen increased interest in the hydrogen space for refueling and dispensing, specifically in these two areas, considerably across the country and across the global value chain. In Europe especially, we've seen considerable increase in sales the past year. In Asia Pacific, China is actually looking at our product for metrology purposes, and there's a lot of excitement here in the United States on the California coast and hopefully through the rest of the country as these transportation chains develop across natural gas pipelines.
Yeah, as usual, California is leading the way for the rest of the country. That's what
Looks to be that way, yes.
Great. While a hydrogen leak may not represent a climate change impact, which is good, I suppose, it certainly can be a safety issue. So, Marc, maybe you talk a little bit of characteristics of Coriolis technology and the Micro Motion HPC. Specifically, what are the characteristics that help ensure the safety and integrity of dispensing applications?
Well, in addition to having the unique capability of handling the dynamic measurement challenges I mentioned just previously, the Coriolis meter is really well suited for this application for that reason as well, which is keeping the hydrogen inside the tubes where it belongs and not allowing it to escape or creating any greater risk of a leak or loss of the hydrogen containment. Mainly because the Coriolis meter design is fully welded So there's no seals or O-rings or anything like that that really need to be broken or that need to contain the hydrogen once the hydrogen enters the meter up until the point where it exits the meter. So that's good. And, one of the other things that we learned in the process of adapting our high-pressure gas meter lines to include the HPC015 and make it ready for hydrogen dispensing was how to use this new austenitic stainless steel alloy XM19, which gives us the strength but keeps flexibility in order to make the flow tubes that vibrate inside the Coriolis meter sensitive enough to be able to measure the hydrogen flowing through, and yet strong enough to contain the really high pressures involved.
And that particular alloy is specifically good for resisting hydrogen embrittlement.
Yeah, that's the other part of the challenge. Because although there are other alloys that are also available that have the combination of strength and flexibility that we really need to be able to design a Coriolis meter for this application, the austenitic stainless steel of the XM19 alloy is not prone to hydrogen embrittlement like some of those other alloys would be. So it's the perfect solution for our needs.
Genny, I understand that there's a companion product suitably named the HPC020 versus the 15 is now being introduced to the market. Bigger model number would seem to me bigger flow rate, bigger capacities. Can you explain how the new meter complements and extends the features and specs of the HPC015?
Sure. The HPC015 was designed for hydrogen gas dispensing, as you know, and Marc has given such a good explanation of what XM19 austenitic stainless steel is. And with that SAE J2601-1 nominal flow rate standard of 3.6 kilograms per minute, we've seen the hydrogen market really want a complete solution for light duty and medium duty, heavy duty vehicles at their refilling dispensing stations, so that a car or delivery truck or semi can at the same station fill up. And additionally, they want that filling time to be fast and convenient for long haul truckers as well as for the average commuter. So 3 to 4 minutes for a car, and then closer to the diesel truck fill time 4 to 6 minutes. So with that in mind, we've designed a sensor that's capable of a 9.0 kilogram per minute or a 7.7 kilogram per minute for the higher pressure rated sensor. And we call this ETO the HPC020 Coriolis. It's in two base models, the HPC020M and the HPC020N, with a capability of going up to a pressure of 16,000 psi. So it's a considerable improvement or line extension to this HPC series, and with this larger flow option, we expect to be able to complete the needs for that dispensing market with this heavy-duty vehicle space.
I'd imagine that a higher capacity Coriolis meter would also come in handy just up the supply chain as well when it comes to filling the trucks used to distribute hydrogen to retail terminals. Is that a target application market for
Oh, most definitely. And we've anticipated this because whenever there's a new alternative fuel like hydrogen or CNG in the past, there's always logistics that are involved with bringing that fuel to the customers. And sometimes that will involve filling up large tube trailers that essentially can become a traveling vehicle fueling station. So that instead of having a fixed stationary vehicle refueling facility in one place, you might be able to fill up a large high-pressure tube trailer with hydrogen and then drive it to a location where you want to have a fueling service there just temporarily, and then it might move on to another community and serve as a fueling station for that community as well. And that creates a need for a meter that can fill up that huge volume inside the tube trailer in a reasonable amount of time. Again, Coriolis technology and the Micro Motion solutions are ideally suited for that as well, and just requires a larger meter like the HPC020, which is targeting this application as well, in order to be able to reduce the amount of time that it takes to fill that truck so it can get on the road and be out doing what it needs to do.
Yeah, that's interesting. I heard about the going on the road to deliver. Sounds more like the food truck concept applied to fuel?
Yeah, it's certainly one solution that different countries around the world have found when they don't have the luxury of an installed pipeline system. It's another good alternative way to bring fuel to those.
Genny, what other sorts of in-plant applications is the HPC series appropriate for? And can we expect to see other extensions of the HPC line?
HPC015 is a great high-pressure Coriolis sensor for chemical injection applications. We've also seen it used in paint applications that require high pressure. We have a line extension that has the C22 nickel alloy that would help cover those corrosive applications. But also, what we're seeing in the future is the need for a higher flow rate, a higher pressure HPC sensor that can help deliver more of that high flow rate that's necessary for the hydrogen market. And everything is rapidly accelerating within that space, and we think that maybe in the future we might have opportunity to see more of these high pressure sensors, possibly for liquid hydrogen and some others.
Yeah, it definitely seems like across there's all sorts of industries kind of moving towards higher temperatures and pressures to get more faster completion of reactions and pushing the envelope more and more across all sorts of industries. So a higher pressure fit the bill, that's for sure. Well, thank you both for joining me today, and for all who are listening, thanks so much for tuning in. Thanks once again to Emerson for sponsoring this episode. If you enjoyed it, you can subscribe at the iTunes Store, Google Podcasts, or wherever you find it. Plus, you can find the full archive of past episodes at controlglobal.com. Signing off until next time.